The first part of chapter 3 starts with talking about the laws of exponents. Can't really do a whole lot unless we at least go over some of the basic vocabulary that is behind the power. Some of this you'll be familiar with, some maybe not. But here you have a power, 5 raised to the second power. The 5 in this case is what we call the base. The 2 is what we call the exponent. And this whole package altogether is called the power. And there's a couple different ways that you can say this. In this case, you can say 5 squared, or you can say 5 raised to the power of 2, or the second power of 5, or something along those lines. All of those things are good when it comes to verbally describing what you're seeing. Whenever you are squaring something, that means you're multiplying the base by itself 2 times. So in this case, 5 squared is equal to 25. Something that is a thing that is a common error when people are simplifying powers is knowing that the exponent goes immediately with the base that it's next to. For instance, if you have inside a set of parentheses -4 raised to the power of 2, this exponent goes with the base that it's immediately with. So -4 is what I'm going to be multiplying by itself twice. A negative times a negative is positive. Your answer would be positive 16. If you saw a question that was similar to this, but it was missing the set of parentheses, so you see the negative symbol, then a 4 raised to the second power, this exponent goes to the base that's immediately with it. If there's no set of parentheses, that negative is not part of what is being squared. So the negative comes along, and then you have 4 times 4, which is negative 16. Notice that the examples in A and the examples in B look very similar, but yield different results. Anytime you are dealing with exponents, you can always refer to the laws of exponents to figure out how to simplify them if you're multiplying, dividing. There's a whole bunch of different rules. So we're just going to go over them one at a time. The first one's called the product rule. Basically, if you have powers that you're multiplying and they have the same base, then you would add the exponents. So you see the example here, x raised to the power of m times x raised to the power of n is going to be equal to x raised to the power of n plus n. The thing that's important is to realize that they have the same base. So for A, I have x to the 3rd power times x to the 8th power. So I would simplify that by adding those exponents, and simplified that's x to the 11th power. Anytime you are not sure if this is something you want to believe, think about x cubed. That's x times itself 3 times. X to the 8th, same thing, but 8 times. If I were to put this multiplication symbol in here, you would notice that there's 11 x's. Looking at B, this one's a little different because you have 2 raised to the power of 4 times 2 raised to the power of 2. They have matching bases. Add the exponents. 2 to the 6th power. Because you know what it means when you raise something to the 6th power, you could actually simplify this further. Multiply 2 by itself 6 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. If you were going to put this in a calculator and in Desmos or anything like that, you could use what we call the caret button. It looks like a small rooftop. You write 2 caret and then 6, and that's how you would put that in a calculator if you wanted to work it out that way. C is a little bit more of a diverse type of question because you're not just looking at one type of power. You're looking at more than one. So I have x squared y times x cubed y to the 4th. I can change the order of this. I mean, ultimately, if I were to write this out without parentheses and I put multiplication symbols in there, this is what we would be looking at. The commutative property says we can change the order of things and make it so that the powers that are like powers are next to each other to make it a little bit more clear that when I add 2 and 3, that's x to the 5th. Y times y to the 4th is y to the 5th. There is a 1 If you don't see the exponent, you can assume there's a 1 there. The next rule we're going to look at is called the quotient rule. Again, we're looking at powers that have the same base. If you are dividing a power by another power and they have the same base, you'll subtract the exponents top minus the bottom. For a, if I have x to the 5th over x squared, I would be subtracting the bottom from the top. X to the 5th minus 2 is x raised to the power of 3. Again, if you had any doubts with this, if I were to write out the 5x's on the top and the 2x's on the bottom, this would give me the power to be able to cancel out 1, 2 from the top and the bottom. Notice that there are 3 left on the top, and that's how I got x cubed. Go ahead and take a moment, do B and C. Pause. Come back in just a minute to compare your answer. The answer for B would be 3 raised to the 2nd power, and you can simplify that further. 3 squared is 9. C is x times y squared. That is the quotient rule. For 3, we have the power rule. The power rule only works if you have a power raised to another power. So notice that I only have one base written here, but I have 2 exponents. And if that's the case, then you would multiply your exponents to get your answer. For a, I have x cubed squared. So I would multiply the 3 times 2 and get x to the 6th power. Again, if I were to write x cubed out twice, it becomes the product rule, which basically states that if you have powers that have the same base, you can add the exponents, and you're multiplying them, you can add the exponents. So this is the same kind of result. It's just a lot more work. For B, 3 raised to the power of 2 times 4 is going to be 3 to the 8th power. You can put this in your calculator again using the caret button. 3 times 3 is 9, times 3 is 27, times 3 is 51, times 3 is 153, times 3 is 459. I've lost how many I've done. There you go. I just went and put it in Desmos. 3 raised to the power of 8 is going to be 6,561. Go ahead and do C. Come back in a moment and see if you got the same answer I did. If I were to multiply 5 times 2, that would give me z to the 10th power. That is the product or the power rule. That's when you have a base raised to a power and then another power. So notice anytime you see just one base, that's what would indicate it's the power rule. Okay, the zero exponent rule, this one's pretty basic. A lot of people, anytime I ask them, and they'll learn this, and then I'll ask like a month later and they will completely forget. Anything raised to the power of 0 is going to be 1. Usually people want to say it's going to be 0, but that's not it. So for a, y to the power of 0 is 1. If you have x squared plus 6 and they are in a set of parentheses raised to the power of 0, it's 1. For b, 6 to the power of 0 is 1. C, again, you have this crazy monomial situation, raised to the power of 0, that's 1. The next one, rule number 5, is the expanded power rule. Notice that inside my parentheses for my base, I have more than one factor. So if you have a situation where you have a set of parentheses that has a base that's raised to a power and there's more than one factor, then that power would be applied to both factors inside the parentheses. Likewise, if you have inside your parentheses a quotient, you can go ahead and you can break off the numerator and the denominator and raise those individually to the power that's outside of those parentheses. So for a, if I have 2a in a set of parentheses raised to the 3rd power, I can simplify that by saying that it's 2 raised to the 3rd power times a raised to the 3rd power, and you would have to simplify that further. 2 times 2 is 4 times 2 is 8. The end result for this would be 8a cubed. for b, I have 6 to the second power, then x cubed raised to the second power. We're kind of breaking this off now into more than one rule because 6 squared is 36. Here we have the product rule, x raised to a power to a power. 3 times 2 is 6. 36x to the 6th power. For c, this is one of those quotient ones. I can break off the top and the bottom. The top is x squared to the 4th power, and the bottom is y to the 4th power. Product rule, power to a power, x to the 8th over y to the 4th. D is starting to be where you're getting into these situations where you're going to have multiple rules happening in the same problems. If I start off by breaking off the top and the bottom and raising them both to the 3rd power, on the top I have 2 squared x cubed. On the bottom I have 3 cubed y squared cubed. 2 times 2 is 4, x cubed. 3 times 3 times 3 is 27. Then we have y to the 6th power because this is base power to a power. For an example, why don't you go ahead and do the following. So I'm going to give you e, which is 4xy squared over 12xy, all raised to the 2nd power. Take a moment, pause the video, do this example, and then come back and compare your answer to mine. Okay, so I've done the first part of this, which was pretty much breaking off the top and the bottom and raising them to the 2nd power. And then I was able to put that 2nd power with each factor on the top and each factor on the bottom. That gave me 16x squared y to the 4th on top, 144x squared y squared on bottom. Notice though, if you do the quotient rule, or if you just do simple canceling out, these x squareds would cancel out. I have 16 over 144. Those are both even numbers. I could split them in half if I want to, dividing the top and the bottom by 2. That would give me 8 over 72. I have the y to the 4th over y squared. 4 minus 2 is 2, so I have a y squared on top. I am noticing again that 8 and 72 can be simplified. 8 goes into itself once, goes into 72 9 times. My end result is going to be y squared over 9. Who would know that this would turn out to be something that looked like that? The last page for this video is looking at the 6th rule, which is dealing with negative exponents. A lot of people have a misconception about negative exponents, that they indicate a negative number, when usually what they indicate is a small number or a fraction of a number, but it doesn't really tell you anything about whether or not the number in question is positive or negative. So you can see a few different examples of what you would do to take a negative exponent and make it a positive exponent. But basically what you have to do is you have to put the example in fraction form. And then in order to take a negative exponent and make it positive, you have to take the base and the negative exponent and move it all to the other side of the fraction bar. And that will make the negative exponent positive. Now I've done that for a. I have to put a 1 up here on top or else it's not going to be a fraction. And that's how you deal with a. And you can kind of see this looks exactly like the example, the very first one that you have. B, again, this works even if you have a number and not a variable. I move my 4 to the -2 on the bottom. Negative becomes positive. This is 1 over 16 after being simplified. Let's go to D. Before I can even evaluate the negative exponent, I'm going to have to use the rule that breaks off the numerator and denominator. So my numerator would look like x squared to the -3rd over y to the -3rd. Power rule, 2 times -3 is -6. Y to the -3 on bottom. Now I have 2 negative exponents, so that means I have 2 things that need to be moved. this needs to be moved down in order to make that -6 positive. This has to be moved up to make that -3 positive. I'm going to have y to the 3rd power over x to the 6th power. This is probably the first example we've seen where we've had a negative exponent on bottom. And again, I stick to the first instructions I gave you, which was you circle the base that has the negative exponent and you move it to the other side of the fraction to make that negative exponent positive. Looking at C, we have -4. That does not have a negative exponent, it has a negative in the front of it. We have x to the 5th. That's not negative, but this is. So that would have to come to the other side of the fraction bar to make that -2 a +2. Let's look at E. I'm going to multiply my coefficients first. 3 times -2 is -6. I'm also going to write this out, and I'm going to put the x's next to each other and the y's next to each other so that we can do the product rule, which is -x. -2 plus 1 is -1. 1 plus -3 is -2. Remember, you have to add the exponents. And then these two have to be moved down. They both have negative exponents. So I have -6 over x y squared. Okay, so I'm going to have you take a moment and do F and G, and then I'm going to come back and go over them with you. Do not do H unless you're feeling amazing and that you want to try it, which would be amazing if you did. It's a lot, I agree. But do F and G and then come back. Okay, if you look at F, things that had to be moved, a to the -2 had to come down, and then c to the -4 and d to the -1 both had to go up. That left me with b cubed, c to the 4th, d on top, and a squared on bottom. For G, I went ahead and I put -2 as a exponent with each factor. So here I am, -2 to the power of -2. 2 times -2 is -4. -4 times -2 is +8. This positive y to the +8 stayed on top. The -2 to the -2 and x to the -4 had to come down. I only got to change the exponents. So when I were to simplify -2 squared, -2 is not inside a set of parentheses. So I have to keep that negative symbol. 2 squared is 4. X to the 4th is on bottom. Look at H. H is really interesting. There's a lot of different ways you can approach H. You can simplify each of these individually. You can multiply across the top, across the bottom. I'm probably going to do that as part of my simplification process. 5 times 4 is 20. If I add the exponents for the x's, I get x squared. Add the exponents for the y. Add the exponents for the z. Multiplying on bottom, 2 times 8 is 16. Add the exponents for the x's. Add the exponents for the y. Add the exponents for the z. Notice this is z to the 0 power, which is 1, which basically means I don't have to write this here. If I had something times 1, I wouldn't have to write it. The only thing I really need to do is simplify the coefficients. 20 and 16 share common factors. I have to move my y down, and I could simplify my x variables. So by the time I'm done with this, 20 over 16 can simplify into 5 over 4. I have 2 x's on top, 4 on bottom. That means I could cancel these with 2 on the bottom. That would leave 2 x's on the bottom. I have y to the 8th on the bottom because this came down. We added the exponents, and then z to the 6th stays on top.